Hello friends, welcome to my YouTube channel. In this session, we will continue our Mahatransco previous assistant engineer electrical solutions. So, in the given question here is consider the following circuit and find the current due to 1 amp source only. So, here we need to find the current here. I is how much because of this 1 amp source only. So, this is given network. So, we can find this kind of problems when we have two or more sources. We can apply superposition theorem. Superposition theorem. According to superposition theorem, any circuit having more than one voltage source or current source, and we can use the individual sources and get the response which is equivalent to all the sources acting together. That means here 1 amp source is acting, 5 amp source is acting, so both are acting in the circuit. Now, but they want to ask 1 amp source only, so I will activate this and deactivate this. So how can we do this? So if you want to apply superposition theorem, if it's a current source means make a open circuit. If it's a voltage source means we make a short circuit here. So here we are applying superposition theorem on this 5 volt source, so that we'll make a short circuit here, that is source zero concept here. So current 1 amp, and here we have 2 ohm resistance, 4 ohm, 2 ohm, and here we have 5 ohm resistor, and we are making a short circuit path in between the sources here like this. Okay, so here we need to find what is the value of I. So if we observe here, these two are parallel combinations. So current source in series with 5 ohm resistor here, and here we have 2, and 2 these two are in parallel. So R equivalent is equal to 4 into 2 by 4 plus 2. That is, here we have resistance 8 by 6 like this. By applying current division rule, we can say that I flowing, I is how much? So it is 1.0. So which is divided into these two parts. By applying current division rule, we can find the value here. So I will find I value here. So this is what we want. So I is equal to the current, total current is 1.0, opposite resistance divided by sum of resistance. So 5 plus 8 by 6. If you substitute this, you will get answer as 0.4 amps. The next question is, which of the following quantity will be reduced due to skewing of the rotor in a three-phase squirrel cage induction motor? So normally the rotors are made to skew. Skewing means making slight angle here. So that means the copper bars which are placing here will place like this. So this is a thing about skewing. Okay. So which of the following quantity will be reduced due to skewing? So parasitic torque, or you can say pulsating torque here. You can reduces pulsating torque in the machine. So only one is correct option. Next one. The given the curves, that is voltage and the field curves IF here, corresponding to which of the following motor. So you can say it's a V curve. So V curve is for synchronous motor. We can also draw the inverted V curve like this. So this curve belongs to synchronous motors. So option is synchronous motors. Next one, interesting question here is, choose the correct option in the reference to induce the current in the loops by a straight current carrying conductor as shown in figure. So here we can apply our right hand rule. Right hand rule concept here. So once the current is flowing, okay, hold the current carrying conductor in a such a way that your thumb represents the current direction and the curling fingers around it represents the direction of magnetic force. We will apply here the right hand thumb rule. What it says that if you are hold the current carrying conductor in your right hand such that thus thumb represents the current direction, this is the thumb, and the curling fingers around it represents the direction of magnetic field. So the north pole here and south pole here. So as because of current flowing in this direction, here we have north pole and south pole. So north pole and fluxes are going to be moving like this around the conductor. Once it cuts the conductor here, So for example, see here. So how the current direction will be? Okay, so they are always perpendicular. So I'll take the circle here. So it is like this. So here we have north pole, and here we have south pole. The conductor is P. The flux lines are entering like this. Once it cuts a conductor, what about the EMF or current direction will in this case? So here, because of this flux linkages here, so by right hand rule, the current direction will be like this. So this is the current will flowing like this. So what is the direction here? This is clockwise. And here south pole is the flux is how it is. So flux is moving from this point to this point like this. Here we have the flux is links the second coil, and the direction of this flux will be in counterclockwise direction like this. So A in counterclockwise. So it is like this. So south pole, and here north pole. This is the flux. Okay, the flux linking this conductor like this. So sorry, here we have north pole and here we have south pole. So here the north pole and south pole, so that it is rotates in counterclockwise direction. Okay, so the option is in A counterclockwise, B in clockwise. So next question here. The output voltage waveform as shown in the figure refers to which of the following category of chopper circuit? So this category of choppers will have an ideal chopper. It's a straightforward question. So ideal chopper. The next question is which of the following follows the property of transmission line? So transmission means it's a reciprocity. They are asking for reciprocity theorem. So in transmission lines it is AD minus BC is equal to 1 is a true. So only 3 is a correct option here. Next one. So SCR will be, what will be the value of a gate source resistance, that is we want RGS in kilo ohms for an SCR if the gate to cathode characteristics has a straight line of slope 130. So gate characteristics means here we have the characteristics are like this slope. So here we have the gate current and here we have gate voltage. So slope M is nothing but Y by X. So VG by IG is nothing but RG resistance. How much it is? 130 ohms. And triggering voltage of source. So here we have a source voltage E, we have resistance RS, and a thyristor connected like this. So here we have VG is a voltage and IG is a gate current flowing, anode, cathode, gate here. This is characteristics. Now the allowable power dissipation is 0.5 watts. Then what we need to find? What is a source resistance or gate to source resistance we need to find here. So we'll get the formula from this as, so Vg into Ig is nothing but how much it is 0.5 watts, and resistance means Vg by Ig means how much it is 130 ohms. So by using these two equations we can find Ig as 62 milliamps. So from this, so Vg is equal to Ig into Rg, that is got 8.06 volts here. So finally after doing all these things we can find the final equation applying by KVL here. So minus E plus Ig into Rg plus Vg is equal to 0. We know Vg value, we know Ig value, we know E value. What is E value? 15 volts. By substituting this value we can get Rg it as 111.9 ohms, but in the given options they are asked as it is 1.11 kilo ohms. That means if you go for the, so 9 means approximate answer will be 1.11 kilo ohms is the approximate answer for this question. Next one, for the waveform as shown below, which of the following options are true? So it is a quasi-stepped waveform which is comes in our three-phase inverters with a 180 degrees conduction mode here. So direct equation you can say. Next one, So here a 50 Hz 3-phase synchronous generator has inductance per phase of X millihenry. The capacitance of the generator and circuit breaker having 0.02 microfarads if the natural frequency of oscillations is 29 kHz. So friends, here they are not given in radians per second, it is given kHz. What will the value of X? So first we will find. So radians per second, W is equal to 2 by F. So F they mentioned 29 kHz. This is nothing but 2 into 3.14 into, so 29 into 10 power 3. So this is the radians per second, and this is equal to omega equal to 1 by square root of LC, or it can be written as natural frequency of oscillation. W is equal to W square is equal to 1 by LC. So we want L value, so L is nothing but 1 by omega square into C. If you substitute these values, that is equal to, we'll get 1 by, so 2 into 3.14 into 29 into 10 power 3 whole square into 0.002 into 10 power minus 6. Why? Because microfarads. If you solve this, you will get the answer as 15. You can check it. So the option is 15 here. And the next one, for the AC circuit shown below, if the RMS voltage across the inductor is 30 volts, what will be the value of inductor? 0.5 Henry. What will be the value of resistor here? So for this question, I didn't find the circuit. If anybody find a circuit, so please share it with me so that I can provide the solutions. Thank you friends. Thanks for watching. If you like my video, please subscribe and comment. Thank you. Have a nice day.